Okay, I should now be live. Hopefully you all can hear me and see me. Let me know about my audio levels. I'm going to start some music. Let me know if that's too loud or too quiet or what have you, because I will have no way of knowing how loud I'm coming through compared to what you guys are hearing. Hopefully you can see me on camera. And yeah, I guess just to start off, let me know about levels, and then I can take questions from you guys. It looks to me like the preview that I'm seeing, I set it to low latency mode, but still the preview I'm seeing is probably a good 5 or 10 seconds behind what you are seeing. Or that should be, you guys are 5 or 10 seconds behind me, like in real life. So if I get a question and don't answer right away, that is why. I have the chat in front of me, and it's going to be on stream when I switch to my monitor view, so that I hopefully will be more easily able to follow along with you guys. I didn't have much in the way of a backdrop, so got 2 divisions and a mini mulcher behind me. Laser cut acrylic sign that I made back when I was an intern at Other Lab, and few of my guitars back there, as you can see as well. Let's see, we've got 10 concurrent viewers. My reasonable expectation for this was to get maybe 20, so this seems not too far off. Okay. I mean, we may as well get started. It's already 1:03, so if you guys have any questions, let me know down in the chat. Do I play only guitars as in, like, in terms of instruments? I, in, like, 3rd grade, started playing percussion in, like, concert band, and did that through my senior year of high school. Yeah, I don't have it plugged into the amp right now. But yeah, I started playing guitar. I honestly don't. I started playing guitar on my 10th birthday. I got an acoustic guitar for my 10th birthday as a birthday present. So I do not take it seriously at all, and I'm kind of not that good. But I am better than people who've picked up 3 years ago, given that I've been playing for like 13 years, you know? I somehow just ended up... I don't know. I feel like it's a thing for anyone who plays guitar and like has any amount of money, that you just like continue to accumulate guitars for some reason. So I have 3 now. I've gone through more than that in my lifetime, though. I've eventually sold that first acoustic that I got, and got another acoustic, sold that one before getting this, or after getting this Martin acoustic. And then it's like the cheapest actual real wood Martin guitar that actually exists. So it's not actually that expensive. But Martin is like the Ferrari of handmade acoustic guitars. Yes, I will be starting a brand new robot design on the stream. I'll give you a 2-second sneak peek here. Five guitars and a drum set. Your neighbors must hate you. Oh, this is not a Battlebot that I'm working on. Team Just Cause Robotics and BNS / Team Bots and stuff are very separate, other than the fact that I am a member of both teams. I mean, I started Just Cause Robotics. I'm like the only person officially in the team, though I've had other people come to help out with it. So the robot I'm working on now would ideally be a 3-pound Beetle weight to compete at Norwalk Havoc, not in May, but in whatever the next one is, I think September. Let me check real quick. No, frickin' Macrium Reflect. Go away. No, July 24th, I guess, would be ideally when it can compete. So yeah, plan is for it to be a 3-pound robot. So yeah, in terms of Bloodsport though, there are plans to upgrade Bloodsport, and also the BNS team, one of the other BNS members, not me, has another designed heavyweight actually that is called Retrograde that we're applying to Battlebots with. That I can't talk too much about because I'm letting him deal with like how much he wants to let on, but there are renders of it you can find on Reddit and on Facebook on the BNS Facebook page if you want to take a look at it. The robot that I'm working on is not just a wedge because you're not allowed to have just a wedge at Norwalk Havoc. You have to have an active weapon. Yeah, active wedge is not really what I was going for. I'm hoping to make a robot that can actually do damage, but that isn't like purely damage focused for once. I mean, obviously Draconid is basically that, but I mean, for a 3-pound for Norwalk Havoc, it's hard to get away with not being able to do damage because there's no other way to disable your opponent when if you stick them against a wall or whatever, Brett can just get them out. Yes, there are multi-bots at Norwalk. I don't know what you mean at the lightweight classes. Norwalk has 3-pound, 12-pound, and 30-pound weight classes. There's 3 different weight classes, so... Lifters are active weapons, but it's very hard for you to build a lifter that will survive for 3 minutes against Lynx or Droopy in the 3-pound class, which is why it is usually not very successful. Sir Spectral's definitely onto me a little bit there. There are some pivoting elements. There are multi-bot Beetle ways. There's no... I mean, it's... When you say, this thing there, it's like... It's allowed within the rules. If people choose to build and bring them, then they are there. But, like, it's allowed. Some events, they aren't, and some events, they are there. But it is always allowed. No, I'm not doing a flywheel launcher, but actually the captain of the Tantrum team, Aaron Hill, is actually building one called Moonshot, which I'm not sure if it's going to be at this next Norwalk, but he is planning on bringing a 3-pound flywheel flipper to Norwalk. No, it's not going to be a crusher. Let me put this back on so that you guys can continue to wildly speculate. This is also obviously like nowhere close to finished, which is why I'm doing this on stream. I just want to have like the most bare bones of possible elements on here. Norwalk Havoc has weird rules. So actually when you have a multi-bot, you're allowed an extra pound of weight. So a lot of people will do multi-bots where they have a 3-pound robot and a 1-pound robot together. I actually did that at the most recent Norwalk Havoc I competed at in February in one of my fights. I threw Mini Mulcher, which is my 1-pound ant weight, in with Division as a multi-bot team. Just one light, yeah. It's only, you know, 1.85, no, 2.9 ounces, a little bit underweight right now. It is not a brushless powered lifter, but it is a lifter, and it does have a brushless motor on the lifter. I already have N20 motors in Mini Mulcher actually, but it kind of broke when I was testing it before I moved. But there's actually N20s in it right now. You can't see because the lid's on and I don't have the screwdriver for it. But it's way faster and like much more mobile now. Nope, like I said, not a flywheel flipper. Somebody else already doing that. Why do I use Fusion 360 for CAD? Oh boy, buddy, have I worked with another CAD program? Let me tell you, I've worked with basically every CAD program. I started using CAD when I was like 13 years old with Google SketchUp, which is the worst program possibly ever devised for CAD besides Tinkercad, in my opinion. Though Tinkercad's not like that terrible, it's just like when Fusion 360 exists and it's made by the same company as Tinkercad, Autodesk, why? Like literally why? Fusion's just better in every way and it's still free. So yeah, why do I use Fusion for CAD? Because I like it a lot. It's super fast. Because of the cloud storage, you can't ever lose your files. You don't have to worry about like running out of storage space or like file organization or any of that crap. The way you can work with it is just like, it's so much simpler. And I feel like Fusion 360 is kind of like to CAD as like Python is to programming languages. Like if you are a design engineer who grew up over the last 20 years using like Rhino or like Katia, you probably think Fusion is like a joke because it's like the easiest shit ever to learn and so easy to use, and it in some ways can instill really bad design practice on you if you just learn it from scratch on your own. But if you kind of know what you're doing, you can do all the same things as all more powerful CAD programs, just maybe less efficiently, other than a few things that you need for like large-scale production or like huge like multi-thousand part designs. So like the stuff I do for my actual job basically would maybe not be great for Fusion. And at my actual job I use Creo Parametric because that's what the company uses, and also SolidWorks. My last job, which I did for 18 months, I used SolidWorks that whole time. And at first I kind of hated it, but I grew to like it. Creo is still just the worst, and I still hate it, even though I've been using it for like 3 months. But yeah, I've used Fusion, I've used Inventor. Actually, I started learning Inventor after SketchUp. So I used Inventor in high school because we had a 3D printer. So I learned how to use Autodesk Inventor to make models for the 3D printer. And then when I got into college, I started using Fusion, and I haven't stopped since, and it's been like 9 or 10 years. So, no, not 9 or 10 years. It's been like 7 or 8 years of me using Fusion for like all of my hobby and robotics stuff. Do I think Fusion's better than Inventor in terms of usability? Fusion's better than almost everything in terms of ease of use. Like, if you don't know what CAD is, then it's great. Inventor and SolidWorks are extremely similar in that both of them have, like, you have to create one type of part that is an assembly file, and then one type of file that's like a part file. And then you assemble parts into assemblies, and then you can assemble sub-assemblies into assemblies, but they're still both assembly files and stuff. SolidWorks is like that. The biggest difference between Fusion and a lot of other CAD programs is the fact that any file can be a part, multiple parts, an assembly, or an assembly containing other assemblies. So it's kind of interesting that way. Like, in Fusion, you don't really have parts, you have components, and any file that contains multiple components becomes an assembly, and then any assembly can contain as many assemblies and parts or components as you want. It is actually a 4-bar lifter and spinner, but it is not at all like Whiplash in the way that the spinner is intended to be used. Fusion is very good. Onshape is alright. Onshape is, I think, made by the same company as SolidWorks, but it's kind of like Onshape is to SolidWorks as Fusion 360 is to Autodesk Inventor. I could be wrong about that. And Onshape, they like changed up their things recently. They used to be like free, and I think now you actually have to pay to use it like at all, unless you have a student license. Katia is not fun from what I've heard, but I haven't had to use it. There is nothing attached to the bar except the motor right now. That's true. That's very bare bones right now. So it's not really intended to be weird whiplash. It's kind of intended to be... Yeah, actually, Tantrum was like partly inspiration for this. I think it's kind of a weird mashup. What I was kind of going for is a mashup between P1, Tantrum, and Sawblaze in some sense. I'll explain more about that in a bit. Maybe at like 125 or 130 I'll get into the actual CAD and explain what I'm doing. What do I think about the current meta of combat robots in general? That's a hard one. I could go on for like an hour about that. I think there are different metas in different weight classes and even just different regional competitions. Like at Norwalk Havoc, because of the way the arena is designed, it really shapes the meta. And you can see with Battlebots the way that the arena floor is now actually really reshaped the meta from Season 4 to Season 5. In Season 4, Tombstone and Deep Sticks punch straight through the floor. And it was made out of a bunch of thin sheets of metal, so you couldn't really use magnets because it just doesn't work that well. But now you can A, use magnets, and B, the floor is like a lot less screwed up throughout the competition, so people really gravitated to using these long forks in Battlebots because of the floor. And in like Norwalk Havoc, I think just like because there are no ways to knock out an opponent other than just completely disabling their robot, since you can't throw them into a pit, and if you pin them against a wall, like Brett will free them at least once throughout the fight, you pretty much need to have a spinner to win. Like, you, in theory, yes, you can win without it, but you have to go to the judges, or the other robot just has to break randomly. So if your robot isn't designed to make the opponent break, then you're just forced to go to the judges every time, and then it's like coin toss sometimes as to if you win. But yeah, I mean, the meta, I think in Battlebots, the meta of vertical spinners is like pretty real, but I mean, Whiplash got into the final too, and I wouldn't qualify Whiplash as like just another vertical spinner. I think Whiplash is really a lifter primary robot, so I wouldn't consider them to be another vertical spinner. But it's obviously a design that wins. I mean, like 5 out of the last 4 champions in Battlebots are vertical spinners. However, at Norwalk Havoc, I mean, Droopy won the finals. And sure, a lot of the winners before that were vertical spinners. I mean, you basically had Shreddit, who won like 3 times, and it's just a fingertech beater bar bot with like a really generic body built around it. But it's just because it's reliable and it like works. And reliability is really surprisingly important. Do my team use... Yeah, I use a lot of Alloy 910 filament in my robots. Basically, the entirety of Mini Mulcher as it existed at February's Norwalk was printed in Taulman Alloy 910. It's a pretty great nylon. And I use a lot of nylon parts in Division and in my... basically in every one of my bots, really. Well, most of the printed components are Taulman Alloy 910. I've been looking into using more of a flexible filament, like a TPU, but I haven't experimented too much with it yet. What weight class? This is going to be a 3-pound robot to compete at Norwalk Havoc in July, I guess. Can I rotate the weapon to the back side? Yeah, this is the whole assembly. I can move it the way it's supposed to move for you. Does this give you guys some idea of what's supposed to happen here? I don't know what the actual range of motion of this will be, but ideally it'll get to about here. Yes, it is more interesting than a wedge. Everything that isn't a wedge is more interesting than a wedge. I'll talk about what the robot's supposed to do soon. Yes, it's obviously not finished. That's probably why it looks weird. It's kind of an overhead, but also not. My method of thinking for a brand new project is usually pretty random, honestly. Like, I come up with things kind of off the cuff. I was actually kind of working on a ring spinner for a while, and it was basically intended to be a meta killer bot, because the way that vertical spinners win is they flip you over or rip your robot to shreds, and if your robot is just weapon and it's invertible, then it in theory can't be ripped in shreds or flipped over. So I was going to make an invertible ring spinner, but I have the design like 85% finished, but I've kind of put it on hold because I think that this new design will be more interesting. Is CAD able to simulate stresses with... Yes, it's called finite element analysis, or FEA. Fusion 360 does have the ability to do that. However, if you have a personal license, I don't think you can. I have a student license I've actually been using for way too long. And eventually I'll probably end up starting to pay, because like it's like $500 a year, which is a lot, but I think I am barely under the qualifications of what you're allowed to use Fusion for within a hobby license, because I am now technically using it sort of vaguely commercially, given that I'm doing YouTube videos and stuff with it. I think they say as a hobbyist, if you make up to $1,000 a year, that you can still use it, though. So from that perspective, I am definitely still good. But yeah, this is like my very unfinished idea for a ring spinner that I had. I think there's just not enough space for the electronics to exist in this, so I have to basically redesign it from scratch. But this was going to be a 3-pound robot with 1.875 pounds just in the weapon system. For the ring spinner, the bar is not meant to be sacrificed. It's going to be an AR-500 weapon. In this, where I am intending for this arm to be basically concealed mostly within the body of the robot, so it doesn't get destroyed. And he plans to make a 30-pound robot? Yes, but also no. I've already made 2 30-pound robots back when I was in college, Karma and Conduit. But neither of those robots would survive at all in full combat featherweight fights. I mean, Karma did, but it was trash. Conduit was meant to be a sportsman bot, and they're not running sportsmans at Norwalk, so until Motorama comes back, I probably... Even if Motorama's back, it's like once a year, whereas, you know, Norwalk Havoc is like 6 times a year, which is so much better. What KV prop drive do I use? I switched from using prop drives in the latest version of Division. I'm actually using this motor now. It is a Cobra 2814 Cobra motors, 1850 kV. So it runs at 4S instead of 3S, and it has a lot more torque than the prop drives. But I was using a prop drive 3000 kV because it has the best power to weight ratio of any of the prop drives. I just needed more torque because Division self-rights with his weapon, which is just stupid. What is this? Yeah, I'm going to get to that in like a few minutes, but this is the very bare bones beginnings of a design for a very unusual weapon robot. Does it lift other robots into the spinner? No, it kind of lifts other robots above. It manipulates the other robot to leave an opening for the spinner, is the idea. Like I said earlier, you may not have been there, but this is basically kind of a weird mashup between the design/strategies of Tantrum, P1, and Sawblaze. Yeah, Lego Combat Robotics is a pretty good idea. of what's going on, but not exactly. It doesn't really lift the other robot into the spinner. It kind of, I mean, you can see it, like, it brings the spinner into play without the other robot necessarily being, like, moved into it. Yes, it is a fork. This is indeed a fork. I don't know if this design's going to pan out at all, by the way. I've not planned out very much beyond this. But that's what we'll find out today. Yeah, we're not building Blood Force. That was an April Fool's joke. Scully? I don't know how to pronounce that name, but Blood Force is an April Fool's joke. Also, a lot of people realized that the vertical spinner Blood Force was a joke, but didn't realize that the TI bar was also a joke. No, we're not spending 10 grand making a titanium tri-bar. That would be completely stupid. No, this project won't use magnets, because magnets don't stick to wood. And again, this is going to be fighting at Norwalk Havoc where there are wood floors. Also, I hate the use of magnets in combat robots. I'm just going to be frank with that. I think it's kind of BS. It's obviously becoming a thing in Battlebots now that the floor can support it, but for various reasons, I just kind of hate it. I don't like anything that gives your robot... I don't really like anything that makes robots work only or best on, in one arena. Yeah, Tantrum's drum spinner has, very little weight in it, but it is definitely a lot weaker than most robots' weapons. A Geneva mechanism? I do actually know what a Geneva mechanism is. Why would I use that, though? A Geneva mechanism is for indexing. It's like a mechanism that allows you to have a continuously rotating element that's like a cam, and it'll cause something to rotate one portion of a rotation at a time. It's used for tool changers on CNC machines, if you're not familiar. There aren't any rules saying you can't use them, I just don't like them. The wood does not have metal underneath on the Norwalk arenas. And even if it did, magnets follow the inverse square law, so the further away that a magnet is from something magnetic, the weaker it gets by the square of the distance. So essentially even a magnet that would have 200 pounds of downforce when it's right up against a steel panel, and you separate them by 3/4 of an inch of wood, it would have probably less than 5 pounds. Okay, we're at basically 130, so I'm gonna tell you guys what my general idea behind this is. So, I don't have a name for this, by the way. Basically, the idea behind this robot is, if you were watching my most recent Norwalk Havoc video where I have Draconid fighting against P1, P1 just kind of comes around, takes up Draconid, and with the front hinge flipper, pins it up against the wall, and then I'm done, which is pathetic. Most robots wouldn't lose that way. I actually duct taped on some pieces onto Draconid after that happened to prevent that from happening again. But essentially, what my idea is that I realize that a lot of people now in the Beetle weight class for Norwalk Havoc are making plans for Starchild, because Starchild has this thwacking overhead spinner. And that is probably the most powerful top attack weapon in the class right now. However, my robot division is in a very unique position to be able to defeat that type of attack. Because if you think about the meta vertical spinners like Shred It Bro, it's like a box that's yay tall, and then the wheels stick out on the top and bottom. So for it to be invertible, the wheels have to stick out on the top and bottom. Whereas with division, I don't care how high the wheels stick out the top, because they don't have to for it to be able to drive inverted. Since it doesn't drive inverted, it just self-rights and gets back up onto its wheels or whatever. So I can actually just put a block of foam that's this thick on top of division, and then as long as that block of foam is taller than the radius of Starchild's weapon, he can't hit me, and that will work against any top attack saw robot as well. So I'm not as concerned about that. But I realized, if you want your robot to drive, and it has wheels, the wheels need to touch the ground. Which basically means every single robot has a severe limitation on how much material they can have between their wheel axles and the floor. So in other words, if you're fighting a saw robot, you can put on special armor that's just to fight a saw robot on top of your bot. But you can't put it on the bottom of your bot, because then your wheels don't touch the floor. So my idea is, I use a saw that'll be attached to this motor. I drive and pin somebody against a wall. I use this 4-bar mechanism that acts basically like P1's front hinge flipper to have the bottom of their robot. The bottom of their robot is level to the floor. I pick them up, and then I push them against the wall. So now the bottom of their robot is exposed, and then I just shove the saw straight into it. So that way, I can cut through the bottom of a robot. So that's my idea for defeating most of like the meta vertical spinner bots. And I don't know if it'll work at all, but I think it'll be cool to try. And I think I can make this mechanism light enough that, and like durable enough that it, in theory, can work. I'm not building an active wedge. It's gonna have a saw. The primary weapon is going to be a saw. The idea is like the top of the robot will be like here-ish, so that the saw's motor is like recessed in the chassis, and a horizontal spinner can't just like climb up and like chop it off as easily. I don't know if that'll work. I might be able to add like a little forky bit here that prevents somebody from climbing up over it. Yeah, I know it's never been done before. That was kind of the... That is why I'm dropping the ring spinner idea, which has been done before for this, because I thought this would be way more interesting. What material am I going to use? I'm going to use multiple materials. So these pieces are probably going to be aluminum. I'm probably just going to have like steel dowel pins as the rotating axles. And then this fork and a lot of other components are going to be laser cut AR500 for sure. I think I have this modeled in as 1/4 inch thick right now, but I can always go thinner or thicker. This is basically... The idea would be I basically take this, and I mirror it to the other side, and then I figure out a way to actuate the arm. I think the trickiest parts of this are going to be A, figuring out how to actually actuate this motion, and then B, actually build a drivetrain around it that is, you know, there's enough weight dedicated to everything else that it doesn't just completely fall apart when it gets hit. Did I miss any questions? Let's see. When designing a robot, do I start with the chassis, weapon, drive, etc.? I basically almost never start with the weapon, because it's a lot easier to build a robot that works and is durable and then add a weapon than it is to make a big weapon and then be like, I want my weapon to weigh 10 ounces, and then now you have, you know, 10 ounces less to build everything else. And also, weapons don't usually win fights. Honestly, durability and reliability win fights more than weapons do. Will the weapon be a hub motor? No, but like, yes. It's going to be a direct-driven saw, because I saw that work really, really well, at least in the ant weight class, and I've seen it work pretty well in the Beetle weight class as well. This motor might be a little underpowered. I might have to move to a bigger one, but all I have to do is make the design wider, and as long as I can support the other end of this shaft with like the mirror of this part, I think it should work. Where do I source screws, steel rods, wheels? So the wheels I'm probably going to 3D print and cast urethane onto for this, to be honest, but I have gotten Fingertech's wheels before. I use Fingertech wheels on Division. They're just the really cheap foam wheels. These are 2-inch ones. I do a lot of weird stuff with wheels, though. Like, some people use Battlebots wheels. I don't like Battlebots because they just suck and they're not designed for traction at all. They're caster wheels. So I made a video on like how I cast my own rubber wheels for Draconid, my 12-pound robot, onto 3D printed hubs, and that seemed to work really well, so I'm excited to try it in the 3-pound class. So right now I have this motor in here as kind of a placeholder, but it's just this one. It's what I used in Mini Mulcher, so it's the 2205. Where do I source screws, steel rods? Oh yeah, so screws and steel rods, though, you can get off McMaster-Carr if you're in the United States, or honestly, you can find them on like eBay or Amazon if you really need to, but McMaster is generally the go-to for finding a thing, and then you look for it somewhere cheaper. As long as you can find it on McMaster, you know it like exists, and other people probably make it. It's better to use a spinner, bar, or disc. That completely depends on what you're going for. That's why I have multiple options for division. I started out with a disc, because the advantage of a disc is that you have really high moment of inertia for the weight of the disc. But high moment of inertia is slower to spin up, but it also stores more energy, so there's the trade-off. For a horizontal spinner, you generally don't see many discs, and that's because every time the tooth passes, you have a huge edge to catch. And because after a certain RPM, for a given diameter, you have like bite, which is like how many times the tooth goes past while the robot's moving forward. So the slower your weapon spins, the more bite you get, and the larger your weapon's diameter is, usually the slower it spins, because most people are going roughly around a 250 mile an hour tip speed maximum for various reasons. Above that, you start to really run into air resistance limitations. It's kind of complicated. I have a whole spinner design video series. There's 2 videos that are like a total of 50 minutes long where I go into obsessive detail about this. But basically, most horizontal spinners spin slower than vertical spinners. So if a horizontal that's spinning kind of slow, it's going against a vertical spinner. If the horizontal spinner has a disc, there's a really good chance that the rim of the disc gets hit by the vertical spinner rather than the tooth catching it. So for horizontals, you tend to see a lot more bars and blades that are like long and thin. For vertical spinners, you see a lot more of like the discs. For division, because my disc is the size of a horizontal's, I had that problem. So the first weapon I ever designed for division, which was a disc, it got bent at one point for that exact reason, because the tooth came around, missed the opponent, and then they hit the ring. So that was bad. But if I had designed it with like way longer tooth and a smaller ring diameter, it could have still worked. Can the motion of the saw be mechanized by pushing them into the wall? So, yes, but also it would suck. I actually was, when I was designing the brushless ant-weight drive that I kind of abandoned, the reason I did that at the start was because my idea was to have a passive flipping mechanism doing exactly that, where you jam this into the wall and it shoves back and activates a piston arm to push forward. The problem with that is you have to think about the energy. So the kinetic energy of like a 3-pound robot driving into the wall, even pushing a second 3-pound robot, is not nearly enough to launch another robot even like a foot in the air with perfect efficiency, and you would never get perfect efficiency. What am I working on? I'm working on this robot here. So the idea, I was just explaining a little earlier, is basically going to be a weird combo of P1, Tantrum, and Sawblaze, where you drive and push the other robot up against a wall, and then pivot this front hinge flipper and bring a saw into the bottom of their robot to cut the underside of the bot so that they can't defend against it, because you can't add extra armor under your robot, since then your wheels don't touch the ground and you're screwed. Whereas you can defend against Sawblaze and other top attack robots by just adding armor on top of your robot. Alright, why don't we try and actually get started on some of the design work. I will try and follow along with the chat as I go, but I can't promise I'm always going to be looking at the chat. So yeah, first things first, I am going to be using a lot of parametric design. So I have set up Fusion 360 with this whole table here. This is called parameters. This is one of the reasons that I think Fusion 360 is just the absolute best. This is for the 3-pound Beetle weight class at Norwalk Havoc, by the way. So these parameters are like, you can do anything with this. You can type any variable names you want. You can make any variable in here dependent on any other variables in here, or multiplications or subtractions, additions, any formula you want. So by doing this, I can change up my design without having to dig into individual sketch files. So like right now I have this saw diameter mocked up as 2 inches, but if I want it to be 3 inches, then bam, it's 3 inches. I have the length of these links all defined parametrically, so it's 1.375. What if I make it 5 inches? and now it's 5 inches. So I can play around with this without breaking the whole model for the most part. Where the linkages actually connect to each other, you can have some problems because the mechanism's motion requires that the relationships between the links not exceed certain amounts. So like if I change this to like 5.5 instead of 0.55, it's probably going to break. Yeah, see, like that, this link isn't long enough to reach down there now, so I'm going to just undo that. But it's Excel, but infinitely better in every way, and for CAD. So yeah, parametric design is fantastic. You can also do things other than just lengths, by the way. Like, I can make a parameter that's like instances. If I had like a pattern where I didn't know how many of a thing I wanted, and make it no units, that would be like 6 instances. So like, if I wanted to map up a saw, I can do that later and say I want 12 teeth, and I'll be able to link that. I can even change the name now to teeth. And then I could also I could make a unit that's like angular degrees or radians. I can change the units of everything. It'll do unit conversions for me automatically within the formulas too. So you can see here, like, this is 4 millimeters, but the rest of these are in inches. I can combine different units within each expression if I want. Fusion is just great like that. It makes everything so easy when dealing with different units. Why am I so smart? I watch a lot of YouTube videos to teach myself things, and I spend a ridiculous amount of time learning to do it on my own. Also, like, I'm an engineer, so I have to do some of this for my job now. I'm a mechanical engineer. I work full-time at a company called Deca Research and Development. They're the company that invented the Segway. Is it better than SolidWorks? In my opinion, yes. I used SolidWorks at my last job for 18 months and still use it occasionally at my current job, and I prefer using Fusion greatly over SolidWorks, but certain people will have differing opinions. Fusion can do a lot more than SolidWorks can for, if you're talking about base packages. SolidWorks has like a bajillion add-ons, but also a SolidWorks license like my company uses is like $3,000 a year, and Fusion is free. So it's kind of stupid to even try to compare them. It's kind of like saying, is this Ferrari as good as a Prius? Like, both of them will get you from point A to point B at the same time if you're following the speed limit. But also, literally, why would you buy a Ferrari just to get from point A to point B? You would not. You know, you use SolidWorks for like professional work for a reason versus Fusion. There's a bunch of differences. What job do you do? I work as a mechanical engineer, and I'm working on various robotics projects that I mostly cannot talk about because of NDA, but the main project I work on is public, and it's a FedEx delivery robot. It's like an autonomous robot. It's like yay tall-ish. It's basically running around on like a wheelchair base, and it's like 400 pounds and can deliver up to, I think, 90 pounds of cargo. What diameter and steel type are my weapon axles? For division, I use a 3/8 inch diameter alloy steel shoulder bolt. Alloy steel is just like whatever. I don't know, like the alloy, but it doesn't matter. It is just called alloy steel. It's very strong and pretty hard. Was it hard to move over from SolidWorks to Fusion? I did it the other way around. I used Fusion 360 in college, and then I started using SolidWorks for my actual job out of college. So I'd used Fusion for multiple years before I started using SolidWorks, and I think it led to some growing pains, but I made this adjustment. Yeah, thank you. You have a shirt. I do not sell these shirts, unfortunately, but I have a couple of them. Yeah, it's a pretty fun job. It still gets boring at times like any other job, but it's way better than the last job I had. Okay, yeah, let me try and actually get stuff done here. The construction lines were the top of the bot. This construction line would be where roughly the bottom of my robot's base plate will be, I think. This construction line is for the saw, roughly the saw diameter. Okay, what else we got? Can the motion, yeah, I already answered that. Yeah, so let me go back into my plans here. So the thing that I would like to be able to use to activate the saw is this guy right here. This is a servo that has 20 kilogram centimeters of torque at the arm. And you can buy off these are like $20 or $15 each, and you can get them on Amazon or anywhere on the interwebs. There is no average dimensional size of a Beetle weight because we don't have size limits here in America because we aren't dumb. But most of them are much smaller than mine. Let's put it that way. So yeah, basically this servo... Oh, do I not have it able to animate the arm? I kind of need it to be able to animate the arm. Let's fix that real quick. Gotta get that pivot joint there. And then this pivot joint here. And apparently that was offset by the wrong amount. Whoop. Alright. That's gonna be not correct side to side, but it should be good enough for my purposes here. Oh, what? That is not on center at all. Why did that happen? Huh. That's weird. Let's try that again. I want you. And you. And the back. And then I want it to be a revolution. There we go. Now I can actually move this however I want. And then I just need to do update out of date component, and boom, that is updated, and I can now pivot that as long as I have the servo actually fixed in place. Okay, so right now I don't have anything to constrain this to. One of the nice things about SolidWorks compared to Fusion, and also Creo does this the same way, is you can constrain things via planes instead of like 1 point to 1 point like it is in Fusion. The way it is in Fusion is a lot faster and more convenient when you like know what you're doing, but when you're just starting to plan things out and you're just like, I want this to rest on a base plate, but I don't know where on that base plate. Constraining it from point to point is like kind of silly, but it is what it is. Let's make a new component here. I'll make this like a base plate. I don't know exactly how big it has to be, so I'm going to parameterize it as well. But I know it has to be joined to this somehow. Wow, why are my axes all like off-center? That's annoying. You know what? I think I was gonna maybe do something more with this arm to make it kind of part of the base. I don't remember exactly. So I'm gonna actuate this. I need to actuate... This has to be fixed, so this pivot point and this pivot point are fixed, which means I have to actuate it at this joint right here somehow. Which means the servo either needs to reach to the in-between two arms, which will be tricky, or outside of both arms, which would be also tricky, or outside of only one arm, in which case it would kind of force it only on one side, which kind of sucks. So I think I'm probably going to go in the middle, because that's probably less bad. So I'll have to have whatever link goes from to servo to here be like in the middle of the robot. The wedge part digs into the floor. That is fine, and it kind of has to some extent. But I can change the pivot point if that proves to be a problem. I'm not sure if this is even going to be a 4-wheel drive platform. If it's 2-wheel drive, it doesn't matter, because wherever the front point is, the wheels are still going to be at the back anyway. And also, like, the idea is once they're against the wall and they're pinned, I'm just sawing into them, and I don't really need to be able to drive anyway. So if the front's lifting off the ground, then who cares, because it's not like they're still attacking me. unless I'm fighting a multi-bot. And even then, like, as long as I've gotten one guy pinned for a bit and I can do this, then I think I'll be okay. There wasn't really a way to arrange this so that it didn't do that. So that's kind of a sacrifice I had to make to be able to get this off forward enough. I usually CAD really slowly, I feel like, compared to like some people, so doing this on camera is not making it easier. New component, base, okay. Start. Okay, whatever. There we go. Now I can just draw a base plate however I want. This is like completely random size right now. It's probably gonna have to be wider than that. Maybe like 6 inches. That's obviously too short. Let's start with 6 by 8. And then I'm just going to create a parameter of base length. Is going to be 8. And then base width going to be 6. And base thickness is going to be an 1/8 inch for now. Do I have any pets? No, I live in an apartment and it costs $55 a month extra to have a cat, which is the only pet I would have considered getting. Reliability is important. Do I have any other bot builders attempting to achieve this with redundant systems? Yes, many robots have multiple weapon belts because weapon belts weigh like nothing. Bloodsport has 4 separate weapon motors and motor controllers, but that's also partly a packaging issue because like you just can't really get one big motor that's powerful enough for their weapon and also short enough to fit inside of the robot. I have 2 cats back where I used to live before I like graduated from college and moved out and whatnot. Have I considered talking about ESCs? Not really, because your motor is like way more important and it drives your ESC entirely. What college did I get my degree at? I got my degree from the University of Rochester in New York. How am I gonna join you? Obviously the base plate has to be behind that part and it needs to extend no further forward than maybe there, but I can also add cutouts for this section later, but I don't really need, I don't want to have to. So that looks about good. Is there a way to splice your own weapon belts? Yes, if you are using polyurethane rubber belts, you can weld your own belts. I tried that for the first version of Division, and they flew apart in every fight. But Tiny Huge, 3-pound little Huge, actually uses that as well, and they were able to do it successfully. Jonathan Schultz told me he basically like lights the ends of the belts on fire with a lighter, and then joins them, and then cuts off the excess that squeezes out when you do that. I tried joining them with a soldering iron and not lighting the ends on fire, which apparently does not melt them thoroughly enough to work. But I switched to timing belts, and they're like indestructible, so I'm okay with not making a change again. So the pivot point needs to be in between, so like maybe here, and then you're going to be all the way over here to be roughly centered. This is going to be kind of the middle. In fact, I can just make a construction plan just to give me a better idea. Of where the center of this is going to be. Wow, why is that rotated like that? That's kind of weird. Give me a corner. No? Okay, fine. I'll just offset the plane from this. That's very roughly where like this left, right, center of the robot should be. So we can now see, you know, I need it to be about this wide for the servo to fit here. Does everyone battle hardened motors? Not in the Beetle weight class, I've never had. Maybe I should with the motors I have now because I had a coil come loose, but that's the first time that's ever happened to me at my last event. At heavyweight scale, you kind of have to some extent, though. But Beetles, it's kind of silly. The motors just don't weigh enough for it to be a huge concern. Like, there's not enough inertia for them to, like, damage themselves, really. For motors, you often just end up designing them yourself, but GrabCAD is kind of the go-to place. I've designed a few motors and posted their models on GrabCAD. Like this one. I think I found on GrabCAD. Which is... sometimes people upload them as, like, mesh files, which is super annoying, but... And then you have to modify it to give it weight. Alright, so the servo needs to mount somewhere in there. I got my base. Construction line for where this is gonna go. It's not supposed to still be a construction line. Probably just have a 3D printed mount for this. I'm just gonna kind of box it in for now. And then start constraining things. So you and you are on the same line. You and you are equal. And those are definitely not supposed to be like that. Horizontal, vertical, horizontal, vertical, also vertical. I forgot that one. Also vertical. To be the width of the servo, which I'm too lazy to measure. So I'm just gonna make it so that's supposed to be 40.1 millimeters. That's 40.3 millimeters. And it automatically does inch conversions because Fusion is great. And then distance between you and you, 28.35. And make that 30 millimeters because I don't really trust that the motor model's that accurate. What printed out of now? My brushless gearboxes are printed out of carbon fiber nylon. And they work well because of that. I am making a weird type of robot that has not been seen before, to my knowledge, that is supposed to push the other robot up against the wall, then lift it against the wall, and then shove a saw into the bottom of it. Yeah, it's free, royalty-free music. It's hard to find non-EDM royalty-free music, so I can change this song if you're not a huge fan. That's gonna end in 30 seconds anyway. Let's make this 1/4 inch. Alright, that looks like a decent starting point. Alright, so if that motor is actually flat against the ground, then you know where the screw holes can line up to be. Oops. Getting confused between my hotkeys and Creo and Fusion now. So the center of that hole is 5.05 millimeters above this. I'm gonna change this guy to not be metric also, because I'm gonna be doing this a lot. Also, yeah, I'm designing an inches deal with it. I live in America. We use freedom units here. Might be able to print the whole base and body of this as a single part, but I really think it's going to need to have a metal base plate to be stiff enough. Maybe not. Servo weapons are great for the 1 pound class. 3 pound class, it can be iffy, but it depends. If you do it in such a way that it's like not going to be directly hit by other robots' weapons, like is my plan, then it's probably okay. Oh, that's still part of the base, I forgot. I'm just gonna turn that into its own component if I can. This is now servo mount. Why is it doing that? No. Not on the sketch plane. I want to be on that plane. Oh, I forgot. This isn't joined to the base yet. Let me do that real quick, just so I have a better reference. Then I don't even have to measure everything. I'm just going to temporarily join you to here. No, I don't need that to be a revolute joint. And then the positioning of that's very far back. Yeah, this part's not going to move, so actually I can possibly put it as close as that. Now, maybe. And it's kind of sticking out kind of far to get to here, but I'll just leave it where it was for now. Actually, I'm gonna flip it. There we go. Wow, that didn't do exactly what I wanted. I didn't do at all what I wanted. I'm going from here to there. There we go. Now I have the pivot to the front. That's what I actually wanted. Whoop. Oh my god. Alright, I'll just leave it. It does not want to do what I want. Oh, it's because I didn't ground the base. There, now it can't move. I hope. It's supposed to not be able to move. Apparently it doesn't want to listen to me, so that's fun. Oh shoot, I forgot one really important thing. This extrude has to extrude to a new body. So my servo mount is not that part, it's the other part. I'm doing a great job of making myself look like an idiot on live stream. What kind of battery, or what size battery? I used way too small of a battery is the correct answer to that. It's a 450 milliamp hour 4S. don't care about you, Macram Reflect. Stop bothering me. What is it we're doing here? We're designing a robot that murders other robots from underneath, hopefully. And fusion is not... Oh, I'm in the wrong context. There we go. It's annoying because I now use Creo for my job for, like, you know, maybe 4 to 8 hours every day, and then I have to go back and, like, do all the hotkeys for fusion that I've been using for way longer, but, like, not as recently. Alright, so I'm just gonna leave that there for now. And now that's joined to the base. And now I'm gonna join... Alright, you can't do that because of this fusion. And now I have... In the base plate, I have 2 bodies. This one is the actual base. This is the servo mount. And within that, I'm going to turn that into its own component. So now it should move separately. There we go. The ones... Yeah, both the arms are going to be, like, linked mechanically. Ideally. I think the idea is that there's going to be a central pivot that goes to both here, and, like, the link connected to this arm is going to be in between those. So it's just going to move both with that one motion. Okay, yeah, where was I? I need to actually add the frickin' screw holes to this thing, so I need to center it first. To do that, I think I can use the align command, which I basically never use. So first I'm going to align this surface to this surface. Why did that undo itself? What? Okay, fine. Have it your way, Fusion. I'll join it because it's not a body anymore. I'm gonna have to move, like, everything around later when I actually figure out how to package this all, but it's fine. Okay, so now I have that pretty much centered on the motor. I can finally do what I was hoping to do like 10 minutes ago, which is add screw holes. So I'm just going to project these tabs, screw slots in there, and then use the hole command. Oh, I forgot. I can do things. I can make it so that you can see the things that I do. You guys, keystrokes show up on screen now. How about that? It's like I'm almost a streamer who actually knows what they're doing. Crazy. So use the whole command here. It is a odd combo, but yeah. I am not involved with Retrograde's design personally, so you'd have to take that up with Aaron, who's the weapon operator for Bloodsport and the designer of Retrograde. Alrighty, no, I'm not going to use a 3/8 16 bolt to hold a servo that has screw holes for like maybe a number 6 screw, because that would be stupid. And I'm just going to make this arbitrarily deeper than it needs to be, because I can 3D print the threads as deep as I want. I'm not going to model the threads because I'll just use a self-tapping screw like I did on Division and on Mini Mulcher. So there we go. So now, instead of having one floating component that I locked arbitrarily into one place and a second floating component that I locked arbitrarily into the same place, I can go back in time and delete the rigid mate that I did there, and create a new rigid mate where I join that. Oh, come on. I forgot it doesn't like that. Now I have all this dependent on that previous sketch. How do I fix that? Is there even a way to fix that? I'm not really sure. I'm too used to like the workflow in Creo where the timeline is like supposed to not update with changes that are done to prevent circular references like this. Whatever, I can just do this. I can just create an as-built joint, which doesn't care about the locations of the two. And then I can go back in time and delete the servos mate. So now it's just joined to this. And now I might be able to move this guy. If I remove its joint, I'm not sure if this is going to work. So I move you, and then I hit capture position, then I rebuild. Does it stay? Yes, the screw holes stay where they want. Alright. Why do those look so wrong? Those aren't centered at all. Why is the servo like slid up on those? That's weird. Even though the servo's not centered on this thing, those holes are supposed to be centered within these cutouts, so I'm not really sure what happened there. Well, whatever. I can worry about that later. I can always redesign geometry later. We're already an hour and 13 minutes into the stream and I've gotten nothing done. Are both Retrograde and Bloodsport going to be entered into Battlebots? Well, it depends on whether the acceptance, or whether the applications are both accepted. So, I mean, Bloodsport's probably going to be, because we did well, but Retrograde, we just have no idea whether or not they're going to want Retrograde to compete or not, and it's not up to us. Actually, I have 29 concurrent viewers. That's better than I had thought. My question is, does that work? Oh, I'll just move the whole base plate too. That's cool. But it kind of worked. I need to figure out a way better way of constraining things than this. The servo that I have modeled in right now is a 20 kg/cm torque servo, which I think should be plenty for this, because it's not going to have like a really long lever arm, so it shouldn't need a lot of torque. Okay, let me try and mirror this mechanism. I think that trying to do the linkages and stuff is going to take me many hours, so I probably just need this somewhere so that I have an idea of like what room I have to work around for the drivetrain. But I think I can get a lot more progress done with the drivetrain with the distraction of the chat than I can with the whole linkage system. So let's focus on that. Also does not saw through itself at the moment. That's another thing I just realized I have to keep in mind. Like the saw can't go so low that it cuts through the linkage here, so that might actually limit how far forward I can have this. Fair team to meet at Battlebots? That's a good question. I had talked to members of a number of teams that I really like before Battlebots, like from Norwalk Havoc. I met Brandon Zielinski of P1 and Jonathan Schultz of Huge. I'd met the captain, the few members from Valkyrie. They're all great people. Maybe the coolest new person I talked to, aside from like the endgame guys, which our whole team was pretty chummy with, was probably Donald Hudson. He's like just an absolutely amazing person and super nice. I mean, not in the arena. He wasn't as nice to us, but in general, he's nice. I also probably need to support this joint without it being supported all the way back there. I'll probably add another leg that extends down to here when I figure out exactly how I'm going to join that. It's not going to be a single fork, like I said. I have to mirror this. Let's work on that now. Let's create a new component. I'm just going to call this the mechanism. And within the mechanism component, I should be able to toss all that crap. If it'll let me. Might not. Yeah? Okay. What if I created the new mechanism in the past? No, I basically am moving back in time. So I'm telling Fusion that the first thing I ever did was create this mechanism component. I think it wasn't letting me put these other components within it because it thought that I created the mechanism component after them. Oh, apparently I'm just wrong. It just doesn't want me to be able to do that regardless. That's fine. That's just going to make it a little bit trickier to mirror. Alright, so I have to decide on an exact mid-plane location, which I kind of did with that plane I created earlier. That appears to have been hidden. So I'm just going to call this my mid-plane. And then I have to mirror, I just realized I don't want to mirror the motor. I have to mirror everything that isn't the motor, and I'm probably going to also need to modify this arm, which is going to make this tricky. So I might have to redo the arm from scratch. But we'll see. When I mirror these, I believe it won't link them because Fusion's dumb. So I guess I can just change it freely afterwards. This is the one thing that I think is way more superior in SolidWorks and in Creo than Fusion is like mirroring is one of the primary things, because you can see that I have all these joints here and none of them exist over here. So like that's just not attached to anything now. So I have to manually recreate every single joint, which is super fun. You're gonna rotate right there. And then you're gonna rotate there. You're gonna rotate there. You're gonna rotate there. And now this guy is just doing whatever he wants over there. So I have to fix that relative to this dude here. So to do that, I'm gonna create a new parameter. Where did my parameters go? Why did it? Oh, never mind, it's still here. Let's call this sauce port width. And I'm gonna arbitrarily set that to be 2 inches, and I'll probably just make it way smaller later. So now what I can do is hide my base and just, I'm gonna make that be the width in between these supports. So I'm taking the left edge of one and the right edge of the other. Oh my god, why, Fusion? Why are you doing this? Why would you choose to flip it and make it 180 degree rotated? Okay, so now, oh shoot, I don't remember which one's the original arm. Okay, yeah, this is what I want. I'm gonna make that the saw support width right there. There we go. That's what I wanted. So now I can add the base back in, which is still not attached to anything, but it's fine. And now you can see these drive independently. And to fix that, because all the joints are mechanically linked, I just have to link 2 of the joints together. So you can go under joints and do motion link. Continue. And now I think it's gonna screw this up because they aren't starting at the same position, but I can at least try. I'm gonna start with the joint that the servo is gonna manipulate, that one, and link it to that one. So now you can see they are rotating the same way in a 1-to-1 ratio. So now the only problem is that offset. So I have to go back in time before the drive link and manually set the angles to be the same so that it doesn't break everything. So let's see, which one is that? That's you. Let's make you 0 degrees. And then you are also 0 degrees. And now if I go forward in time, I think it'll fix it. Oh, no, it didn't. Okay. Because it had a capture position not clicked. There we go. Oh, I have to fix it again still. Okay. Capture position. That one doesn't matter. Now I can go and link them, and it will actually work. Yeah, there we go. That's a mechanism right there. Okay, so now you can see obviously this is way too wide because I actually want to support the end of this shaft. I don't know exactly how I'm going to join the saw to this motor yet. I also might still use a wider motor. I might have to have like a prop nut clamp onto it somehow. So for now though, I'm just going to change the width to something that looks a bit less ridiculous. That seems vaguely reasonable to me. Okay, so now we have a much better idea about the front profile of this robot. Which also tells me this base plate's probably not going to have to remain... It's probably not going to remain a rectangle. I'm probably going to need to like taper it in at the front and have some sort of like angled wedgy thing on the sides here so that a horizontal spinner just like doesn't just instantly wreck these forks. That was always kind of going to be part of the plan. The nice thing is if I have a fixed thing at the front... Actually, no, I can't really have a fixed wedge that goes right up to these edges because then when this is trying to push things against the wall, that wouldn't be the frontmost thing anymore. So this is going to have to be maybe a bit more complicated than I'd hoped at the front, but I'm going to have to figure something out. Hello, you're seeing me trying to design a robot, but being very inefficient at it. No, I can also... I think I can reference the mid-plane at least with reference to this. I'm not entirely certain this is going to do what I want. But it might. Changing the motor is going to be something I hope I never do. But honestly, it shouldn't be that bad, because as long as I can move it forward and back a little bit, I can just undo these 4 screws and like pop it like straight out. So I mean, yeah, if there's a bearing like attached to like the motor's actual shaft, then yes, I'd have to like somehow pull this whole mechanism apart to get it out. But that is going to be something I just have to deal with when I come to it, I think. So yeah, U to U. Oh, I can't type a distance in there? Why can't I type in a distance? That's freaking stupid. Okay. So we're gonna create another offset plane that is arbitrarily the base width divided by 2 away from the first plane. I'm gonna call that my alignment plane. Where did the alignment go? There it is. And then I'm going to align you to the alignment plane. And then hide it. There we go. So now I have the base plate centered left to right over this whole thing. Okay. Any other questions while I'm still being very slow at this and I have to figure out an entire drivetrain from scratch with absolutely zero planning other than just throwing Division's entire drive system onto this? This is going to need to be copied over, isn't it? Yeah. I really hope I don't make changes to the design of the one that's on Division that I also need to make to this one, because I'm going to end up basically separating the two. What updated? Oh, the motor updated. This is going to be a 3-pound robot, yes, to fight at, I think, July 20-something, Norwalk Havoc. Okay, so... File management in Fusion is, like, kind of annoying, but it's a lot better than digging around on your desktop in folders and shit, in my opinion. So what I'm going to do is I'm just going to save this as... to this folder. So basically these two designs are no longer linked in, or this design is no longer linked to the one that's in Division in any way. This is a CAD program called Autodesk Fusion 360. It is the best, and everyone who designs robots and doesn't already have a paid SolidWorks license from their job or something should probably use it, because it is free. Oh, I forgot one thing. I need to hide the frickin' key, because why? Two-wheeler forward? That is a great question. I wish I could tell you. I think I'm gonna start designing it around being two-wheeled, and if I somehow end up with like enough weight that I can make it four-wheeled, then fantastic. Just gonna hide that key. I set the material of the key to be air so that it doesn't impact the weight. What is that? Assembly contests. This is like from a new Fusion update. Context is broken. Well, I'm just gonna pretend that I don't see that because I don't think it'll matter. No, on-shape is not free, so it is not for the win. So these guys, I'm gonna end up with two wheels towards the back, obviously. They're gonna have to be joined somewhere, some offset from this guy, and the wheel needs to fit in there, so I'll probably do this similar to how I did Divisions, where I have some 3D printed mount, and then a titanium panel or some other thin metal panel. Because these mounts, the wheel shafts are not that long. The shaft sticking out of the motor is this piece here. So you can see how far it sticks into the wheel. So since I don't have to use foam wheels on this, I'm probably going to use cast rubber ones. I guess I don't need as thick of a wheel. I also could definitely make this not be a unprotected wheeled robot. I think because, I mean, I have so much space at this back section here, like, I think I may as well just do protected wheels. But the thing is, with protected wheels, like, the main benefit from having protected wheels is that you can, like, doubly support the shaft with another piece of armor on the side. And the shaft's just not really long enough to allow that, so I'd have to build some feature into my wheel hub that sticks out, so that I can have another bearing or bushing or something on there. But I mean, all things considered, that's like not that difficult to do. It would also mean I have to design a whole new wheel hub though, because then I can't like stick on the wheel from the outside of the robot, which is gonna be a pain to change. So I'll have to like pull a whole side off to get the wheels, but oh well. I mean, that's gonna be the case for literally any robot where you have the wheel supported by the side panel or any side panel on the outside of where the wheels are to begin with. So it's not sacrificing too much. The other thing is I designed this current version of the gearbox to be like plate mounted to this face here and just have a thin armor panel. So I could still do that, but it would be way more weight efficient if I could just kind of have this 3D printed housing be like, you know, mountable from one side or something. But that's something I'll play around with later. I'm just gonna get a general layout for now. I keep putting M for mate because that's what the command is in SolidWorks, but then I'm like, oh, I'm using Fusion, and it's J for join in Fusion. Just inset that a little bit and a little bit. That's gonna need to be a lot of it. Wow, that's... why does it do this? Obviously, I want you to stay still, and the motor to move. Ground. Oh, I'm working in the wrong context too. Whatever. That's probably not helpful. I'm just gonna change this guy. That's now the main chassis assembly. And I can, because Fusion doesn't want to let me insert things into assemblies I've made already, I'm just going to reinsert it from scratch here. So now the base is fixed within the context of this file. What motor is that? It is an 1806 2300 kV. They're surprisingly difficult to find for the price I got them for, but I got like 7 of them for $5 a piece from HeliDirect, and then they like almost immediately went out of stock when I got my last 3 of them, so oops. I talked to a little bit to the guy who sells the Robotics gearboxes, who I'm totally blanking on the name of now. Gus Collier. And he said that he has like slightly custom versions of them because he needs like different motor shafts than they come stock with, but for his gearboxes, his brushless gearbox systems. But you can check out Robotics if you don't feel like being me and designing a hella complicated brushless gearbox housing yourself that just weighs a bit less than the metal ones that he sells, and it doesn't really cost too much less, but it is my one is like a little cheaper. But anyway, he said that every 1806 motor basically comes from the same single factory in China, and unsurprisingly, you can't really find them for very cheap anymore, given that they come from one source, and that source may have changed their pricing so that all the resellers are just like, well, I can't charge, you know, $5 for this if I'm buying it for $12 now. So they all seem to be more in like the $15 range. But for what they are, they're still really good. They have about 4 times the drive power as the Vision's brushed setup had before, and at half the weight or less. It was like an insane switch. I still have like 3 ounces to play with in Division because of that. Okay. Any more questions, you guys? That a bit further in. You know what? I'm just gonna parameterize that because then I can change it. Wheel from rear. Oh, I can't do minus. manual. Okay, so now I can just edit you, make this be negative wheel from side. Whoops, and you can be wheel from rear. And now I can play with those values without having to dig open that context menu every time. Oh, I can make a context menu for that? That would be nice. I should probably make a hotkey. Yeah, I should do that. I just got a new mouse that's like the same one I use for work, and it has the ability to like program macros into all the buttons on it, so I should probably just set up like my thumb button to do that. That would be super nice. If you're getting started on your first bot, should you 3D print it? Well, let me answer your question with a question. Do you own a 3D printer already? If so, yeah, probably. If not, I mean, it depends if you really want to invest that much on your first robot to buy a 3D printer. Where was I? Oh yeah. I was changing this one. That looks pretty good to me. Modify, change parameters, 3 dots. Where? Which 3 dots? Oh, no, it's not that. They change the menus around kind of often. Under tools. Oh. Oh. I thought that they had the hotkeys and stuff under here. I guess not. Right under the tools section. It just says manage materials. Unless I'm looking at the wrong tools, then I don't really know. Alright, I'll worry about that later. Alright. I've got one motor. Now I need a second one. That would be helpful usually for making your robot, you know, go in both straight lines and being able to steer. So I'm just going to join this the exact same way, but I need to make sure I do it on the right side. There we go. Okay. We got that. And then I can modify the base to have slots for those wheels that are positioned relative to those same offsets I created so that they'll move with the wheel, which is nice. Nope, that's still off. Let me project this though. It's easier. So this is the center line that I have. That is 1.4667 or 1.4677 inches away from there. So I need you to be rear 1.4677 minus wheel from rear. No, what is it? I just need wheel from rear plus something to be that. And the wheel from rear right now. It's 0.7. Okay, so it's 0.7677. I'm bad at mental math. So that way it'll stay that way, no matter what I set the wheel from rear to be. And then this needs to be here. And obviously needs to be wider. Okay, so then that would be 0.75 basically, minus my side offset. So that's 1.25. So that's a negative 0.5. Okay. There we go. And then, last but not least, I just created a little construction line right down the center. And you can just mirror that rectangle over this line. And then finally, make my wheel cutouts. And those were not long enough wheel cutouts. Alright, so now, the reason I went through all that trouble is if I want to move the wheels forward or something, I can now change this to like 2 and it'll just move the slots with the wheels. So that I can adjust that later. Okay. Obviously we're nowhere near the weight limit, but I'm just gonna change the material of this part to be nylon and then see where we're at for weight. Oh, I forgot the base plate. Let's see, if the base plate was like... I guess I could make it titanium. That's 1/8 inch thick right now, so that would be way too thick though. What if I make it... What does Senkosen even have as options for titanium? Let's see what we got here. Materials, metals. Titanium. Okay, they go... Oh, they do have 1/8 inch. That would be probably way thicker than I need. And this is what I use for the front wedges on Division 3, or the 1/16 inch thick, roughly, titanium. So let me just make that 0.063 for now. And now we can see how we are on weight. So we have 20 ounces out of a possible 48, is it? So that is 1 1/4 pounds used out of 3 pounds. Not terrible. Not terrible overall. Obviously, I need to flesh out like everything with this more, but that at least tells me, like, proof of concept wise, that this like can probably exist as a full robot. Have I used nylon webbing as a linkage? No, I don't really know what you mean by webbing. Do you guys have some idea of when you want the stream to end? Because I was thinking I'd go 2 hours and then just kind of see where it goes from there, but I have not gotten nearly as far as I thought I would within this. We're coming up on the 2 hour mark now, so I'm okay with going longer, but if people don't want to watch, I'm not going to. At a peak of 52 concurrent users, like an hour ago, wow. That is kind of nuts, considering that Norwalk Havoc had like 400 their last stream, and I got like an 1/8 of that with my far less general appeal stream here. Okay, so I have this weird servo offset there. So I have to figure out how to do like literally everything with that. I feel like that's gonna give me so many difficulties, just because like I'm gonna have a frickin' saw, and that means I can't have anything that goes like all the way across here, because the saw would just cut through it. So because I need to do something, let's work on a saw blade, why don't we? Alright. I don't know if I think I googled some saw blades and like saw that 2-inch saws exist. I'm still figuring that out, that's why I'm thinking of this now. I think I was trying to go with like the smallest that would like reasonably reach, but also not like cut through all the links that I need, because like I'm limited by how big the saw can be based on the geometry of the arm. So like this link here, there's going to be an axle that extends through these two pieces. And to make the mechanism stronger, I was hoping I could extend it all the way through this whole width. But if I do that, then like the saw blade can't be much bigger than it is drawn in right now. So this is like the 2-inch. You can see if I went to like a 3, I think it's, I forget what the exact size is that a lot of circuit saws, but like if I go to like a 3.5-inch blade, like now I'm cutting straight through that link, so like I can't do that. But I can always just make the saw arm longer. I can just make it like, you know, much bigger, and then that's not a problem anymore. But now it's like sticking out super far, and a horizontal spinner can come up top here and crush it. So I'm thinking I probably am going to try and stick with smaller. Yeah. I think that Top Kill, the saw bot that I made in college, used a 3 3/8 inch saw. And it looks pretty... Even that, it looks kind of comically large on a Beetle weight. By cantilevered mount, you mean like I just don't even have this other arm here? Yeah, I definitely considered it. I think that would just be a matter of this has to be way thicker. But then, like, the rest, this other half of the mechanism isn't, like, doing much, and I still have the same motion. It's like, this link still needs to be here, so I figured, like, I may as well just add the rest of this material here and then support the other side and have it be better supported. But, like, maybe I could just deal with saving the weight, get rid of, like, half of this arm, and make this one thicker, you know? I probably could. I don't want to pull up Discord right now, because I'm sure it'll show, like, secret Bloodsport chat that no one's supposed to look at, but I appreciate you saying that. I'll take a look at it later. Now, I'll just show you guys this. I'm just googling around for existing saws. I swear I saw somewhere. It might have just been a Dremel tool. Obviously, I can just, like, order an 1/8" thick, like, AR500 blade laser cut from Sync Set or whatever, but also, like, there's no point reinventing the wheel if these things, like, exist and they're already, like, cheap. The Dremel Saw Max is still 3 3/8". That's still 3". Yeah, it seems like there aren't really commercial saws that are less than 3 inches. Yeah, you're right. It does need to have... That was another concern, is like... I have like the motor can up to here. So, and like... My idea was, you know, it extends forward to the point where the motor can becomes about flush with here. Because now this is how much reach I get. And that's already... I'm at 0.38 inches. So that is, you know, way thicker than any robot's bottom plate is reasonably going to be. And I have to assume that I'm not necessarily pressed, like, right up against it. But, like, I thought that was, like, pretty much the functional minimum for this sort of thing. Maybe I can... If I'm making my own blade, though, I can go, like, 2.25. And just, like, get closer to this joint and not have to change anything else drastically on me. And now the amount of reach that the blade gets is 0.7 inches. So, like, I think maybe that's a good idea. Alright, time to make a parametric saw blade. So we're gonna go with... I already made a teeth thing. Let's go with, like, 18 teeth, because the more aggressive looking saws that I had on Draconid were 18 tooth, even though they were a 6.5 inch saw. And then I'll say tooth size. Oh. Let's start with that. What the hell? Oh, I had to enter twice. Okay. So now I have this one, and that's going to be distance of the saw tooth. That's kind of small, but I'll be able to change it later. And then what I can do is this. So like I said, I'm going to be parameterizing. Whoop. Construction line horizontal, construction line to here. And then this becomes 360 degrees divided by the number of teeth. So this is now the space for each tooth. So yeah, that tooth is super shallow, and I'm definitely gonna fix that later. And then I want some rake angle, probably. I'm doing this entirely just at random right now, just like what I think looks kind of cool and vaguely like saw teeth I've seen before. This is not going to be like, for sure, the best possible tooth geometry or whatever. That looks kind of cool. I'll add like a fillet here. I'll do a tangent line so I can set a better idea for the rake angle. Whoops, that's... Let's make that like 15 degrees. Oh, that didn't do what I wanted. And that's gonna be no more than like 70 probably. And then I want to move this back a lot more. Whoop, not you. You and you are going to be on the same horizontal line. But you, why is that length like set? That length should not be constrained. Oh, that's why. I had it set to be a horizontal as well. Oh, actually kind of like, what if I just do that? Alright, we now have what is clearly the best saw blade ever designed. No, obviously I'm kidding. I forgot a bore. That's kind of important. That didn't do anything. And then no, it's gonna be servo. I don't know what you mean by cork, but now I just do a circular pattern. And I'm gonna do a body pattern about this axis, the number of teeth. And that's a saw, right there. Oh wait, no it's not, because I just realized that created a shitload of stacked bodies. I actually did this kind of wrong. Should change that to features. Now it'll join them, I believe. Nope, it didn't join them, because this is still a new body operation. Okay, well, that's awkward. That's an easy enough thing to fix, though. I just need a separate feature for the pattern. Just show my sketch here. So now that is a join feature. And now, if I do a circular pattern of this tooth feature, now I should be able to do exactly what I want. Alright, so now is the cool part, where I can play around with it and see how it looks. Alright, how many teeth do you guys think is going to look good? I feel like I can get away with longer teeth for sure. Let's go like 0.25, that's going to look ridiculous. Holy crap, that's definitely not a saw blade anymore. Nope. Alright, I'm going to change up the geometry of those teeth a little bit to not look so stupid. Clearly making those equal was not the move. Also, this angle's like way too high. I'm just gonna change this to a straight line. Okay. The direction the saw spins is the way that all saws should spin. It should grab the opponent and kick them into my robot while cutting down. I mean, it's less important for this kind of design, but I don't want to, if I'm pinning them against the wall, I don't want to like kick them up away from my pin, I want to kick them down into the floor. So this is the correct direction. The teeth looks really dumb. Let's get some reference images up in here, why don't we? This is what I like pictured a sawtooth as. Are they like really low count blades? Oh yeah. I mean, that's kind of cool looking, but a little complicated to do with what I did. I can definitely do that. The gullet maybe is a little harder, but yeah, you do have a point. This is a tungsten carbide tipped saw, but it definitely is for made for ripping wood. Actually, that's remarkably similar to what I accidentally did at the start. A lot of the metal cutting blades are much higher tooth count too, so maybe I don't want to go down such an aggressive tooth path. This looks pretty rounded. That's an 80 tooth? What's like the smallest tooth count that I'm seeing here? 60, 50, 36? Okay. What if I go with like 30? No, it just looks dumb. Those teeth are too big now. Okay, let's try that for starters. And then I can add some aggressive fillets here. Not that aggressive. Oh, didn't like that. Huh. Okay, well that's annoying. Alright, now I have to pattern both of these features together for it to not hate me. That's much better. Okay. It's starting to look like a saw that could actually exist. See if I can't do a little relief. Just like 5 thou relief. That's a lot actually. Should give it a tiny bit less of like a super, super sharp tip that'll just break off instantly. Alright. Okay, so we've got kind of a saw. If I made this a 2-inch, would it look stupid? No, not really. If I go much bigger, it'll probably start to look ridiculous. But 2.25 seems alright to me. Okay, cool. So we have a parametric saw. If I feel like adjusting the tooth count later, I can. Right now it's 24. If I make it 30, that still works. If I make it 40, it's probably gonna break the fillets. No, it didn't really. Make it like 20 teeth, maybe. I think I'll stick with like 24 for now. It looks like it'll work well enough. I'll probably, if I end up using a higher speed motor, just go with more teeth, because that way it's taking less of a bite on each cut and doesn't need as much torque. So then eventually I'll figure out some way of joining this to like the motor can properly, but for now I'm just gonna mock join it so that it's there. You know, yeah, if I join it to the motor can itself, then it basically just becomes a matter of replacing the whole motor with the saw glued to it or what have you whenever I need to swap out blades, which kind of sucks because these motors are discontinued, but I have 3 of them. Alright, I'm starting to look like a robot now, or like a fighting robot now. Do I have an AR500 profile? No, oh yeah, I do. Why is that not saved in my favorite materials? Now it is. Alright. We're still at under 22 ounces. So this saw by itself, being 1/8 inch thick AR500, is 1.436. Oh wait, I forgot. I think that Senkoutsen relabeled because they had different thickness than they thought they would for their AR500. Yeah, it's 1/10 of an inch. There we go. Now it is a 1/10 of an inch thick blade. Now it probably weighs even less. So yeah, that saw by itself, 1.15 ounces. Not too bad for a weapon that can, in theory, slice through a lipo. Okay, cool. I think it's also not the most weight efficient though, so I'm probably just going to do a little bit of lightweighting because I can. Like, it doesn't need to take stupid amounts of stress. Going to draw a construction line here. Make that be vertical. Oh, it's got all my axes tilted. That's kind of weird. Don't really matter what I'm doing here. And then just need that distance there. 4488. That's fine. No, that's pretty big. Actually, I just want to go to What is this CAD for? This is CAD for a 3-pound combat robot that I hope to fight at Norwalk Havoc sometime in July that will saw through the bottoms of other robots after pinning them against a wall. Face, there it is. So went from 1.15 ounces to 1 ounce. That is not a large weight reduction, but it's something. What is that in grams? That is 4.25 grams. Okay, well that was basically pointless. I may as well just not even bother with that, to be honest. Just gonna suppress all those things. Pretend that never happened. Yeah, I don't know, like, I'm okay with streaming this design, even though it's like designed to counter very specific types of bots, because it's designed to counter types of bots due to the fact that they can't add armor against it. Like, the only thing you could do is if you're designing your robot from scratch, like make the base plate out of something that's harder to saw through. But like, you can't make it that thick. You just can't. You could maybe put some extra armor panels in between the bottom of your robot on the inside and like your battery or whatever, sure, but like most people pack their robots pretty tight. You don't have that much room to play with inside either, so I'm hoping this plays on a weakness that's very difficult for people to really, you know, do something against. There's definitely different types of robots that this will be basically useful against too, which is unfortunate though, because like, I mean, the height that this reaches is not that great. This is like, maybe, I don't think this could even hit like Star Child, unfortunately, when the saw is like all the way up, which is kind of unfortunate, but I could maybe just like add like an optional extra long arm, because all I need is just longer motor wires. Just have it be like up here or something to fight like Tiny Huge or something like that. It'd be pretty funny. Can you make a Beetle weight weapon out of aluminum? No, but also yes. No, if you are talking about the whole thing out of aluminum. It's just too soft. But you can definitely do aluminum with like steel insert teeth or whatever. It's like hard to do it properly, and you kind of need like access to precision machining to do it right, but it can happen. Will I be able to find weapon motors with the same or similar dimensions? As in, like, multiple of the same motor have the same dimensions? I mean, I have 3 of them already. They're pretty damn consistent. They're not going to have as tight of an outside diameter dimension as they would have for some of the internal stuff, because for balance it's not as important as long as it's actually round. But I've seen many people do, like, hub motor style weapons like this, where they just, like, glue shit to the motor can. So, because I have the ability to measure the motor, actually laser cut something that's exactly the correct diameter, and also do some post machining if I have to make it fit perfect, I'm not as concerned about that as maybe somebody else would be if they have no access to machining equipment. But I think honestly I can just use a Dremel to get the fit perfect and just undersize it from the laser cutter. So yeah, I have this as 27.7mm or something like that. Let me do that too. Forgot about that. Nope. Is it 27? Nope, that interferes a bit. Okay. Oh, it's 5-3. 5-3-1-5. Oh, so it's 1 1/16 inch. That's oddly convenient. So yeah, so the problem with adding a full wedge is that the wedge needs to exist at a plane where the arms are out. But then when they come in, I need this to be what's pushing them against the wall. So if I have a wedge here, that's not possible. Which is definitely one of the difficulties of this design. Like, I'm gonna need to probably make all these links, like, pretty beefy. And maybe even add some extra support on the outsides of these or something for this to work. And it's kind of like, you can always make a thing stronger, but if you can design it in a way that the other robot can't hurt it in the first place, that's usually better. So if I can just minimize the ability of a horizontal spinner to like hit this and knock it sideways, which I think is like by far the worst loading case for this, in some way, then it'll be better. So like, even if I just like add things that stuck out attached to these forks that angled so that a horizontal spinner couldn't hit them as easily, that would probably help. I could probably do plastic. I could probably get away with like a TPU piece maybe that's like joined to these somehow. That might be interesting. If I had like screws that just stuck really far in, that were like self-tapping plastite screws, maybe like an inch long, at a few places into the TPU, that could actually be pretty interesting. Just need to see where the links overlap and where they don't. Is going to be another thing. Like the limit is pretty much where these two are going to hit each other here. It would, yes, it would work if you do it right. The difficulty is doing it right. UHMW can't be 3D printed though, so it's like I have to machine it, which yes, I could do, but machining angles and like slopes onto UHMW is really time consuming, and if you aren't doing it yourself, really expensive. Let me just mock up something real quick, just to get some idea. No, I did. Okay, thought it did something else. Well, the problem is that if it's 2D, I don't think it's really going to work. I'm not sure what the best way to demonstrate what I'm trying to do is. I think... Whoop. Nope. Nope, that's not joined to the thing I thought it was joined to. If I make this like flattish, This is more or less... I don't know. Yeah, this is more or less the orientation it should be in. Can I lock this in? Yeah, let me lock this in real quick. I'm just gonna create a joint limit, minimum and maximum for this. Oh shoot, I'm doing the wrong joint. I have no idea if this is right direction or not. That's definitely not how that's gonna move. It angles down like nothing. Okay, that's definitely not the one I want to limit then. So you go from about 28 to about -63. Yeah, that's not. There we go. Okay, I have joint limits. Yay! I can just move this freely to extents now. So now that's like basically you're just gonna stop. I can't like drag it past the limits anymore. So now I have a reference for like where I want to start and stop at. So got this guy here. And what I'm gonna do is I'm gonna sketch a line. Just like fucking off somewhere over here. And then I'm gonna sketch a profile. Sweet. Oh, it didn't like that. Okay. Why didn't it want me to select the sketch? That's weird. Why is there a lock symbol on there? I'm not really sure what that means. Whatever. I mean, I'm fine with just doing this. It's just gonna move the hole with it, which is kind of stupid, but it's fine. Anyway, this is kind of more what I was thinking as like a 3D printable thing that could deflect a horizontal. This is for a 3-pound robot, Dylan. And like, if you have ever CNC machined anything, you can look at this for 2 seconds and be like, yeah, fuck that, because it would be so difficult to like fixture something like this, and just like any attempt to actually machine the different sides of it would just take forever. Will we get to see test box videos? Yeah, of course, when I like build it. Like I said, the fixed wedges, the problem is that like this moves back. So like if I have a fixed wedge, it's gonna be here, right? So here's my wedge. Now the other bot, I want to pin them against the wall, and I need the saw to like get into them. But if the other bot's like pressed up against the wall like here, the saw can't reach them. They have to be here. Swap wedges for forks against verts. Yeah, I had been thinking of trying to figure out a fork. I definitely do want some kind of like I definitely need some kind of a hinged fork that's like on a fixed mount at the front for fighting like beater bar verts. Which will still make it trickier to use this weapon, but if they're short, I don't think it'll be too difficult. What would I 3D print the wedge out of? I'm thinking I want to experiment a little bit with TPU, but if that fails, then I'll just go back to Ally 910 nylon that I used for like every part of Vision and all the printed parts on Draconid and such. I don't really like that angle too much. Change that real quick. Whoops, that's the wrong sketch. Do I have a straight line reference? No, but I can make one. Dominic, what? How do you categorize how far a handful of beans goes? Are you talking like the centroid of like the combined mass of all the beans? Like how do you even measure that? That's the only problem that I have with your question. Yeah, sweeps and lofts are like one of those things that you never think about existing, and then you like do something horrendously inefficiently, and then you're like randomly looking at CAD tutorials and find out about them, and you're like, holy crap, this would have saved me so much time. Yeah, they're pretty great. Why is that not fillet egg? I want a fillet. Seriously, I don't understand why that doesn't want to round, but whatever. Average distance between the nearest and the furthest bean. The nearest bean's gonna be like probably falling out of my hand as I'm tossing them though, so I think I could probably throw the can further. The thing is, like, both a bean and the can, an empty can, have a low weight to surface area ratio, so they both will get stopped by the air before you can throw them that far. I guess if there's a tailwind, though, I could definitely throw the can further. I'm gonna fix the frickin' holes being there, because that's just stupid. I need to figure out why that happened. Oh, I can just do that just like an extrude and just not have them come with it. Perfect. Yeah, one thing that I think could work well for fighting a vert would be if I could hinge off of these. Let me just model in some extra holes because I need them anyway for the CPU parts. See, when I actually know what I'm trying to accomplish in CAD, I'm like really fast. But when I'm doing stuff from scratch, it takes me so long to figure stuff out like this. I mean, like, I spent 3 months working on the first version of Vision, and it was trash, and I scrapped the entire thing as soon as the first competition that I did with it. And built a brand new one with none of the original mechanical parts, basically, except for the weapons and the like actual motors and shit. No, I'm not gonna do that because Whole Command exists, and Whole Command is God. Why is that not joined to this guy? You are on this line. All right. So the nice thing about the Whole Command is that because Fusion, it doesn't make it a huge nightmare to deal with sketches again after you reference something off of them, you can do something like this, where I create a pilot hole through this component and this component, and then I bring up the same sketch again, if I can find it. And then I can just use the whole command again. And this is the other... There's two really cool things that you can do here. Number one is I can change this to a clearance hole and only go this depth. But the other cool thing that you can do is you see how it creates this like drill point. Sometimes that'll end up in your other part. So you can actually change in the objects to cut menu. You can just tell it, I no longer want you to cut this body. So like, you see how there's this, it's gonna be kind of hard to show, but you see how there's this flat wall here? If I didn't do that, if I sold it to cut both, then some of that clearance hole goes into the plastic part, and you can see there's now like a cone shape in the orange part. That's one of the really nice features in Fusion, is like being able to toggle on and off exactly which bodies a hole goes through. In pretty much every other CAD program I've used, you don't even get the option of having it affect multiple bodies that aren't in the same part. And one of the things I hate the most about Creo that I have to use for work now is that you can't have multiple bodies in a part, period. Every single separate thing needs to be its own part file, so making things that are referenced off of other things is just an absolute nightmare. I didn't set that parameter. Did I not set the front fork thickness? Let me try that. When did that get created? Okay, I have to go way back in the timeline. Oh no. I may have like imported that. Oh no, never mind, we're good. Will this break everything? Let's find out. The answer is no, because Fusion is smart. Okay. Setting up parameterization correctly can be tricky at times. Like, it's pretty easy to back yourself into a corner. It takes some practice, for sure. Like, I have to be careful that I set that to be the thickness parameter instead of just whatever number I just set the thickness parameter to, because otherwise it wouldn't update if I change this again later. Are all of these thicknesses not parameterized? I really think they are, because they do look kind of spindly to me. Yeah, plastic ants, I would totally be really into if there was anywhere to fight them. Which is one of the reasons I built my arena in the first place. Front hinge tippers, flippers definitely have their place. Battlebots may or may not be that place though. But they do have a place. I'm gonna get rid of you. Oh. seems way more aggressively angled to me now than it did before. For some reason I thought this was going to be like flush with the ground. Bison's pretty legit. I mean, I lost to him because of my own stupidity, but it's still a really good bot for sure. I think I joint angled this a bit too conservatively. Where did I set your joint limits? I don't think joint limits show up in the timeline, so I might be searching for a while. So to figure out which joint I even did it to, because there's two joints that are like, or 2 or 4 joints that are on top of each other. I'm gonna guess it was you. I guessed wrong. Was it you? Nope. Was it you? Nope. You? There it is. Okay. That's super not helpful. Yeah, I think it was that. I went from 28 instead of 27. Yeah, I fought Bison in the most recent competition. That fight did not go very well for me. Okay, so yeah, that looks better to me. The nice thing about a 2-wheel drive platform is you don't have to worry about how much weight's on your wedge, because as long as it's below... As long as the line between here and here doesn't intersect your base plate, the front of your wedge is on the floor. It's kind of a placeholder because I haven't figured out how to attach it to the motor, but like the teeth and shit, I'm probably gonna keep, or I might change it around a little bit, but this is the size that it needs to be for this current length arm. Do I want to experiment the links to try and get the saw lower when it's back? And still far enough forward now that I have a bigger saw. I can try. This might break horribly when I start messing with it though, because I feel like the joint limits are just going to become completely arbitrary, but... I made this like a while ago, so let's see if I remember what link lengths are which. So I want to be the saw to be further back, that means I need, I think, this length here to be longer. Let's try that. Nope. That's not happening. Okay. Okay. So that was 1 inch. And oh, never mind, I didn't lock my that did the exact opposite of what I wanted. I don't know what's up with this Halloween theme music. Let's just skip you. Why is it not letting me drag? Yeah, so that did the opposite of what I wanted. So I went from 1 to 1.25. Let's try 0.8. That's kind of just changing the angle of where the front ends up. It's not really changing where the saw ends up, which is what I was kind of going for. There is no tip speed limit because Norwalk is fucking insane. Realistically, though, you shouldn't go much above 250 miles an hour because of purely just air resistance limitations. What is pivot Y? Oh, that's like the actual positioning of those pivots. Oh, I do have a saw arm thickness. I made the saw arm thicker and it broke something. It broke multiple things, actually. What was that? I see nothing wrong with you. What's the deal? There's a problem with something I did after this. So this positioning right there, it suddenly takes issue with. But why? And now I can't drag this timeline back. What the hell? Oh, it's letting me modify it right now. Okay. What exactly was moved? Okay, so we have... It looks like the relationship between one arm and another may have been what broke it. I don't really see why. Okay, well, let's just undo all of that until it's not broken. There we go. Yeah, linkages are trash for, like, making adaptations to your design once it's kind of set. That's kind of why I did that beforehand, because I didn't want you guys to have to stare at me doing exactly what I'm doing now for like 3 hours. 4-bar mechanisms are no joke to design, especially when you actually have to account for the torque. I moved the weapon arm into the floor plate mounts. What? There are floor plate mounts? I don't think I made any floor plate mounts. Oh, it looks like this is just hovering here for some reason. It's probably not great. Why is the Y offset? Huh. The base plate is like, or these are like floating on top of the base plate for some reason. Even though I thought I joined them directly to it. This is just the joint between one saw arm and the other. So either the base plate isn't actually joined to the saw arms, or they joined with an offset of the thickness, and then I changed the thickness, and that screwed it up. Yeah, I think I just had some janky stuff going on because of the length is changing. Oh, I just realized I had that at the end of the timeline too. Okay, so I didn't fix it, but it's still working. So I don't really care. What did I change? I don't remember now. There, okay. I've put it back, whatever I did. Okay, so that's definitely going through. Yeah, so that's not able to go that far forward. I think this should be where it was before. More or less. Yeah, the plan is for this servo to actuate it, I just have no idea how. I need to tie a linkage between this rotation, whoops, this rotation and this whole like mechanism somehow. I was hoping I could just tie a bar between here and here, but it needs to not get cut in half by the saw, which is the tricky bit. The saw goes down to like there, and you can see if I draw a straight line between those 2 points, the saw intersects it, so it has to be pretty thin. Am I going to be able to use this self-right? Absolutely not. There's no way. I don't think that's... I think that I'd have to attach some weird long thing to the servo to accomplish self-righting via, like, directly through this mechanism. Like, this mechanism, there's not really anything it could do to self-right. I will probably figure out either a way to incorporate servo motion back beyond the limits of where this can go to write it, or just like add some other sort of stream mech. If I could mount the servo beneath the saw, yeah, but then like doesn't it just get cut in half? Maybe not. But I also need this to go back, so I only have space up to like here anyway. Whoop, I broke it. Okay. Oh my god, it's been almost 3 hours already. I really didn't get very far on this. I mean, I have extra weight, but the rest of the robot's not designed yet, so I don't know if I actually have extra weight. Yeah, I can definitely extend this further down. I'm also kind of thinking now, what if I just belt drove it from this pivot point? Because then I just have to connect a straight line between here and here. And as long as that belt's thinner than the space between the saw blade and this arm, like, there's no reason that shouldn't work. I have heard many things about OOTA, and it sounds like it's a much more active Discord than a Norwalk one, which is already distracting enough. Yeah, I think I'm probably leaning towards belt driving this system, if I can. Just because that's so... it's like something I've done before, and it would be super clean. And the only issue I would possibly run into is if I had something that sticks out on both sides of each of these links that could run into the belt. But I can just space the pulley away from this a little bit. I'd be probably 3D printing the pulley to begin with, so I don't think that would be too difficult. Facing down, it's through the faceplate. Tips on starting CAD with Fusion? Look up tutorials from Product Design Online and Lars Christensen, because they are the best and they have thousands of hours of tutorials between them. I don't know why that would be sketch. I mean, it's still torque transfer. Belt to a servo to drive a pivoting joint. It's like not that big a deal. Oh, I see what you're saying now. So if the servo's like not on the actual base plate. Can I do that quickly? Okay, well, that moved the whole thing with it. Yeah, I mean that would definitely be Having the servo raised and then having the arm be at the lowest position when this is like all the way forward, kind of, or you could even have it just kind of mirror the angle of this for the most part and just go like from there to like there or whatever. Yeah, I think that's the mechanically simplest possible way to do this. If I use a timing belt, it won't slip. Toothed belt. This is not a 5-pound robot, it is a 3-pound robot. There are no 5-pound robots in the Beetle weight class other than Droopy, because it has no wheels and is allowed a 2-pound weight bonus. Yeah. I'll have to think about it. A belt. The only problem with the belt is that servicing it would be kind of a nightmare, because it's like in between this whole mechanism. So if it somehow did break, then it would really suck. But like, I've never broke one of Division's belts, and they undergo such an insane amount of stress every time Division hits something. I'm not too concerned about the belt actually breaking. Would it require more torque per belt? The nice thing about a belt and pulley is that a pulley is the same diameter all the time, so it would be a consistent amount of torque required. Whereas with the linkage, like the amount of mechanical advantage that you get changes drastically depending on what angle the thing's at. So you can actually run into more problems, I think, with the linkages, to be honest. I'd have to actually do the math to see like how much mechanical advantage I get / might need, but like, because I'm not trying to lift up the other bot, I don't think I need that much force. It's more how much force do I need to shove a saw through them, and that's going to depend on how hard their base plate is and how effective the saw is at cutting through it. Not really anything I can directly measure or control. Yeah, I have tooth on both pulleys with Division now. You should watch my latest overview video, I talk about it a lot. There's like a lot of shenanigans that I had to pull to make that work. Alright, let me work a little bit on something that isn't the linkage system, because we're rolling up on 4 hours, or 3 hours in now. And I have, like, nowhere close to a full robot. Let's try moving the wheels in a bit, and then what if I just used, like, solid plastic around the whole thing? That would be super nice and easy to just do, like, a unibody print or something. Maybe even TPU. Oh, I can't go that. I can't really go that much further in. Nope, that's still intersecting. If the other bot doesn't ride up the wedge, then I'm pretty much screwed, to be honest. Yeah, this is my first time streaming. I mean, I've been talking to a camera for over a year for the actual recording stuff, so like, I'm used to that aspect of it. Yeah, I guess I either have to make the base plate wider or the side armor not that thick. Or I can just make the wheels thinner, which I was probably going to do anyway. I'll just start with this. Is 120 grams a lot for 1 pound? I have no idea. I don't really have any good sense of scale for 1 pound bots. I've only built my one that has like a stupidly overpowered blade. Why is that an angle? Why? Back is parallel. Failed to solve. Try reversing dimensions. What? Did it create like an angle somewhere that it? Because I feel like it did. That's what I want. There we go. Yeah, if you count like the entire weapon assembly for Mini Mulcher, I think it's about half weapon. It's pretty stupid. I think I might end up with some weird shenanigans here where, like, the front doesn't actually have a solid piece behind it, really. I could probably actually make this able to drive inverted by just not having this be too high. At least then I could move. I just won't be able to self-right. But I think that's pretty important, having it be able to move upside down. In Division I have like 30 millimeters of height, so I can go a bit more than that. Figure out what the absolute highest that the saw gets to be is. The highest point, really. I guess I can just always drive it back down or whatever, but maybe yay high. Am I going to drive on the saw? Yeah, I kind of have to. I think. I'm not going to have the saw powered when I'm trying to do that because it would be opposing the way I'm trying to go. Maybe I could set it to reverse and just have it be a third powered wheel, though. That would be pretty sick. So I just need to create a line like from here to somewhere that doesn't prevent the wheels from touching the floor. So the thing is, it's not about having some wheel exposed, it's about having wheel that is tangent to, or perpendicular to the floor, right? So the question is, where's the floor? So I'm just going to attach this line here. So now, basically what I'm thinking is, like, the highest point in the worst case scenario is going to be, like, the saw, maybe. So as long as I create some point that's like in a worst case position above the base plate. I want that fixed relative to the base plate. So if I imagine this line is where the floor is going to be when this robot's inverted, I just need to make sure that there is tire exposed along, and that there isn't any point like further away from this line than the tire. So in other words, I need to cut away all of this material here. This is where I was kind of talking about before is helpful, where you can just tell it what bodies you want to cut through. But in this case, I'm only intersecting stuff that are not in the same exact file, so it doesn't really matter. Probably want to flip the drive gearboxes to the other side, because those are also kind of not really exposed, but like they could be exposed. Black Rabbit has casters? Why? Yeah, so the problem with having the saw on the floor is because this sharp is going to dig into the floor. So like, you're right that I would ideally actually want to have it so that I was riding on like the plastic wedge that's like maybe slipperier. But thankfully, as long as I have it in like a position like this, I can do that, because now the highest point is the wedge, as long as the positioning works out correctly. Yeah, see? So we're still good. Yeah, I don't want to add extra wheels just for the ability to drive upside down. That's like so much extra weight and complexity. Okay. I think this is like a decent place to maybe stop. I'm not going to stop right away, but there's like a reasonable amount of a robot built. Not built, but you know what I mean. Kind of figured out. Okay, I definitely need that to come forward more. If you guys have more questions, ask them now, so I'm probably going to sign off in like the next 30 minutes or so. Maybe less. How much what would cost? Actually, no. The side armor can actually come up pretty close. Well, since you haven't bought a Just Cause shirt, given that they aren't for sale, probably not gonna happen. Have I decided on the battery? No. Have I decided on the electronics? I mean, you can see I'm just stealing Division's same exact drivetrain, so I kind of have the weapon motor figured to be one from Mini Mulcher, just so I can reuse parts I already have. If not, it's probably just going to be a 2207. No, it doesn't have a name yet. If you guys have suggestions, I probably won't name it until it's like more finished, but I'm open to suggestions. Better supporting it? Yeah, so what I could do is like have this bar kind of extend out along a huge portion of the length, at least forward, because this one's kind of not gonna work backward, but I can have it extend out a lot more forward, and I will probably have some either metal or 3D printed kind of block that'll act sort of like a nut strip, so I can bolt from the bottom and then bolt this into it from the sides. The main thing I'm concerned about is like where it's mounted to the base plate. Oh, I can also come like almost straight down off of. Actually, that's not true. No, I can't. I was gonna say come off of this, but no, that's not gonna happen. But yeah, I think the most important thing is going to be figuring out how to secure these pieces to the base plate as securely as possible. For battery, I might try and get away with one that I have from older versions of Division, because this is not going to be as power hungry as Division. I'm pretty sure Riptide is almost certainly an already taken name. I couldn't tell you what bot it is, but I can't imagine that that's not a thing. That name just sounds way too obvious. Yeah. And it's whatever, what in God's name? Okay. It's whatever the F this is. Looks like somebody was trying really hard to show off that they have a Mercedes. Yeah, I have no clue what that is. How much room do I have back here for what? Yeah, so the side panels can kind of come up pretty frickin' far. Did you say bronze? Why would they use bronze? Oh, yeah, I'm sorry. Riptide, you're totally right. There's literally a bot that just applied called Riptide, made by Ethan Kurtz. Yes. They're kind of billing it as a replacement for Yeti, and they apparently have the support of Yeti's Captain Greg Gibson as well for that, so I'm excited to see if that actually pans out, but who knows if they're going to be accepted again. Yeah, it is the guy who made Rival, Ethan. He's, like, very ambitious, and also, I'm pretty sure he told me he's, like, still in high school, though. Or maybe he's, like, just about to start college, so, like, I don't know if that's gonna be something that adds to or detracts from his chances of getting accepted to be on the show, because, yes, there have been several high school teams on Battlebots before. Very few of them have been even marginally successful, however. At least in the modern reboot seasons. Bloodsport Hexbug would be pretty sick, but I don't think it's gonna happen, unfortunately. But if it did, that'd be great. Somebody modified the Bite Force Hexbug into a functional Bloodsport Hexbug. That was really cool to see. This is starting to bother me too much. I did that outside. That's supposed to be part of the front fork or something. Oh, I guess it doesn't matter. It just has to be part of the front fork mirror assembly. I feel like I used to be able to reorder things a lot more easily, but now it doesn't want me to. Let me see if this will work. No, it's still mirrored it outside of this. That's annoying. Oh, I also didn't even add the holes to of these front forks. Easy fix though. This is where what I'm talking about with the body selection is helpful, because you see it's trying to cut through this. I just have to tell it that you can only cut through the front fork mirrored and the front fork itself. Now it can't do that anymore. Oh, I just realized that hole's not going to work though, because it's going to intersect with this. Whatever, I can deal with that in a minute. Where are you, holes? Yeah, that was definitely not placed correctly. All of these are gonna hit the like this. If there's a screw head sticking out of there, there's like no place where it won't hit something. I don't think, because the head's gotta be bigger than this. I don't know why I thought that would work in that position. 2 screws at the top and bottom will probably work, but I don't really like the idea of holding on an entire wedge section with just like 2 screws. Might have to add some more along the bottom. I think I need a wedge under the saw. I don't think so. This is gonna be pushing the robot that I'm pinning into the wall. By this point, they're almost vertical already. And if the robot's boxy, like most of them are, then they're probably just about to fall vertical anyway. And then I start cutting in. Did I get to watch all the off-camera fights at Battlebots? No, not all of them. We were busy working outside during a couple of them while they were airing in the pits. And also keep in mind that when the fights were showed on the screens in the pits, that we had no audio and didn't get to see anything that happened after the 3 minutes. So any judging decisions were like, you just had to ask the teams when they came back in. Have I thought of direct driving the saw arm? Like how? That would mean there has to be a motor like on this axis, which I have no idea how I would manage that. Are the rear wheel placements final? No. Not much of this is final. I think you might be right that the wheelbase is a bit too long for how wide it is. But I can change that pretty easily. If I change the base plate length, is it going to break everything? Let's find out. Nope, it looks like I didn't even parameterize that properly in the first place. This might break everything. Let's find out. It didn't break everything. How about them apples? Alright, that's obviously too long now, but... Are you talking like a wedge like under, like in here? I don't see how any horizontal could get in there. The 250-pound Lynx-like bot is called Rival. Or sorry, called Riptide. But it doesn't exist yet, because, you know, he's just applying to Battlebots, so you're not going to be able to find much on it. Okay. I think I generally like the idea, or like the direction this is going, but there's still a lot of things to figure out with it to make it actually work, and I have to package electronics somewhere where they don't get sawed in half. But I mean, there's a good amount of internal space here. Let me change some of the plastics materials to nylon, just so that I know that they're denser. And then see where we're at with weight. Oh, what happened to my mirroring for the front section? There we go. Oh, it mirrored that within here. Oh, that's annoying. Do I have a favorite Battlebot? Oh, it's tough. I like a lot of them. Whiplash is definitely one of my favorites. Valkyrie is pretty legit as well. And huge. They all kind of are inspirational in their own ways. Okay. This may very well not work at all. In fact, it might actually be easier for me to just have a direct-driven arm and a direct-driven wedge on two separate servos. I think that would kind of just be a matter of weight, if it's worth doing that. But honestly, I think I could probably get enough torque out of maybe a slightly bigger servo than this to just drive the arm. Then the problem would be I still would need them in like weird locations, but I could maybe have one servo on one side driving the saw arm and a servo on the other side driving the wedge pivot, and that might not be total crap. I would have to build something kind of bizarre to get the wedge to rotate the way that I need it to move the way I need it to, though. Favorite Bloodsport blade configurations? The one that don't break are pretty great. Like the disc. I did really like the look of the bot with the disc, though, for real. Okay. Well, I think I'm at a pretty decent stopping point. How about this? I'll say we're gonna call this off at 4:30 p.m. and I'll just take questions from now on. Save this so I don't lose it. Oh. Okay. Taking questions from now until 4:30 p.m. EST, which is in 9 minutes. How did you guys feel about the stream as a whole? Was this like actually worth watching for you guys? I don't really know how this comes across. I don't know if I would have wanted to watch 3 hours of somebody fiddling around in Fusion, but maybe I'm just not the same as my audience. I don't really know. Are there like issues with the stream? I just got a random notification that there's no data from YouTube, but I don't know what that's about. It says the stream status is excellent now. That's weird. Oh, great to hear you guys are enjoying it. Yeah, I might do more of these in the future. I mean, it's like... editing videos takes a really long time, so legitimately it takes more than 4 hours to put together even, like, some of my simplest videos. So this isn't a terrible use of time, since it's like, I set it up once and it's like... content. Woo. But at the same time, I mean, I've had like 50 people watch this at a peak, whereas I could release a good video and have it be watched by like many thousands of people, so it's definitely not going to replace my edited YouTube content for sure, but I might be able to do this, maybe not with some regularity, but like every like month or so, potentially. Yeah, I'm glad to see that's actually the thought process is important to people, because I thought that was one thing that's like, there's not like a good way to condense it for like even like a 10 or 20 minute video that's like watchable. Do I plan on making changes to Vision? Yes. I have none of them planned out yet, but I'm gonna do very minor changes to it, is the plan for May. I have about a month, so I don't want to do too much. I'm probably going to keep pretty much everything except for the front forks, and I might try and add a configuration to fight beater bars because there's too many of them, and I currently lose to them pretty hard. But I basically just want to fix the only things that aren't working right now, because I have been doing that for every iteration, really. And moving to a different weapon motor was kind of a forced design change, based on the fact that the one I was using before didn't have a big enough shaft to take the loads, and the bearings weren't big enough to take the loads, and I wasn't really able to get the special clamping pulley that I needed for the size shaft that was on that motor either. So that's one of the reasons I moved away from the prop drives in the first place. Any other questions? The chat seems to be pretty slow at the moment. Need a lot more water next time. Division blade is my favorite. I definitely like the cutter blade the most, which is the most recent designed. One of the reasons it's featured here. I think it's like, I mean, it's not like the best of all possible worlds, but between my asymmetric disc and the S-shaped blade, this is kind of the best of the both worlds. Working now. Yeah, I get confused about things, not so much because I'm unfamiliar with Fusion, but because I keep bouncing back and forth between the CAD programs I'm using for work and Fusion, and I forget which things work in one versus the other. I think if this wasn't the first time I'd used Fusion CAD to do anything complicated in like months, I probably would be slightly more put together. But it definitely is a complicated program either way. Like, no, I don't claim to be an expert. Like, I've used it for a long time, but it's not like I used it for 8 hours a day for a long time. I do like stints where I do like a ton of CAD for like a month to make a new robot or something, or make modifications for a few weeks after a competition or whatever. But it's definitely not like my full-time job to work in Fusion. It's my full-time job now to work in Creo and a bit of SolidWorks. Yeah, finishing Mini Mulcher is definitely going to become more priority once I get the arena to its new owner. But I was hoping I could do that this weekend, but he ended up being super busy. So once that's all sorted and I get some vague idea of like when there's going to be an actual Antweight event, I'll probably do more with Mini Mulcher. But I basically did a round of upgrades to it that's like 90% finished after Norwalk because in February because of how it like barely moved. And I have this PLA prototype here, which is a version that uses N20 motors for drive, and it's way better already. And I switched to a more powerful weapon motor as well. So it's already kind of upgraded. I might change the way that the front attachments work and design a few more of those. That still needs to be worked out. But for the most part, that's kind of like mostly done. Let's see if I missed any questions from earlier. I'm not going to call the robot Tantrum Blaze 1. People still watching. How long have you been watching for? Because according to my analytics here, the average watch time is like less than 11 minutes. I have no idea. I think both Division and Drizzle, if they fought, do very random things. So it would pretty much come down to luck for the most part. I've really upped Division's drivetrain with the brushless drive, so it has a lot more control than it did before. But Drizzle actually has like probably a better armor package and an even more powerful weapon than Division has, from what I've heard from its builder at least. I guess I shouldn't be surprised the average watch time is pretty low then. I'm guessing a bunch of people just like click on and click off within the first minute. Okay, that's cool. At least a few people follow along all the time. Alright. Last chance for questions before I sign off. What bot do I fear fighting with Division? I mean, it's not like there's just one. There's definitely several robots that are not good matchups for Division. I have not heard of a whacker drive. Welcome for the stream, though. I think that one of the... whenever I go to Norwalk, I'm basically like, which robots are actually here that I think could take out Division? It's like... Eruption, apparently. Lynx, almost definitely. Droopy would be pretty tough. Starchild, if I didn't have a good config set up already for him, would be pretty tough. But I think I could outdrive him like super easily, so maybe not. I don't know. There's a few that are like There's a lot that would be basically crapshoots. Okay. If there aren't any more questions, I think I'm probably going to call it a night. Thanks for sticking with me, those that stuck with me for a long time, and then everyone who's still here. It's been fun. I'll probably do this again at some point, whenever the hell I have another robot to design. Hopefully I can get a lot more progress made next time. Probably be something a lot simpler than what I'm working on right now, so maybe I'll just have to do a bit more pre-planning so I can get more progress. But yeah, not too bad. Alright, see you guys.